Infinity and beyond infinity, and beyond. Let's dive into the wonders of infinity with Zoran the Dragon narrating infinity and beyond. Introducing the concept of infinity and its role in the universe. Greetings, brave explorers. I, Zoran the Dragon, am thrilled to take you on a journey that stretches far beyond the stars into the mind-boggling concept of infinity. It's a word that holds mysteries too vast for any dragon or human to fully grasp, but together, we'll explore how infinity shapes the universe and the mathematics that govern it. So, take a deep breath and get ready to soar beyond the limits of imagination. What is infinity? Infinity is a number larger than any other. But here's the twist: it's not a number in the traditional sense. It doesn't have a fixed value, and you can never reach it. No matter how high you count 1, 2, 3, and so on, there's always something bigger. That's what makes infinity so fascinating. Imagine flying through space and never reaching the end. That's the essence of infinity. No boundaries, no limits. The ancient Greeks were some of the first people to think about infinity. Zeno of Elea, a Greek philosopher, created famous paradoxes to explore the concept, like how a fast runner would never catch up to a slow one if they kept dividing the distance between them. It might sound confusing, but these paradoxes showed how tricky infinity can be. Infinity in mathematics. In mathematics, we use infinity in many ways. One of the most important ideas is the infinite number line. No matter how far you go in one direction, positive or negative, you'll never reach an end. There's always one more number. This endless nature is a perfect example of what mathematicians call countable infinity, a type of infinity that we can imagine as an unending list, like counting whole numbers. But infinity doesn't just stop there. The famous German mathematician Georg Cantor showed us that there are different sizes of infinity. For example, the set of all whole numbers is infinite, but so is the set of all points on a line. However, Cantor proved that the infinity of real numbers points on a line is larger than the infinity of whole numbers. Mind-blowing, isn't it? Cantor's work helped to revolutionize mathematics and our understanding of infinity. He showed us that infinity wasn't just one idea, but a concept with multiple dimensions. Infinity in the universe. Let's take a look at how infinity plays out in the vastness of the cosmos. When you gaze up at the night sky, you're looking into a universe so large that we don't know if it ever ends. Astronomers call this the observable universe, the part of the universe that we can see with telescopes and measurements. But beyond what we can observe, the universe might continue on forever. It could be infinite. Even the expansion of the universe hints at the infinite. Right now, the universe is growing larger every second. Edwin Hubble discovered that galaxies are moving away from us, and the farther away they are, the faster they're moving. This expansion could go on forever, leading us to a future where galaxies are so far apart that we can no longer see them. But no matter how far we explore, we can never reach the edge because there might not be one. The infinite small infinity doesn't only apply to things that are unimaginably large. It's also hidden in the tiniest corners of the universe. For example, if you take a piece of string and keep cutting it in half, you could, in theory, keep going forever. The pieces would get smaller and smaller, but you'd never actually reach the end. This is known as the concept of the infinitesimal. The field of calculus, developed by Isaac Newton and Gottfried Wilhelm Leibniz, uses the idea of infinitesimals to calculate areas under curves and rates of change. It allows us to deal with quantities that are infinitely small, so small that they're almost zero, but not quite. Calculus is essential for understanding everything from the motion of planets to the flow of electricity. Fractals, infinity and patterns. Let me introduce you to something called fractals, beautiful shapes that repeat themselves infinitely, no matter how closely you look. One famous example is the Mandelbrot set, discovered by mathematician Benoit Mandelbrot. This set creates stunning, complex patterns that repeat at smaller and smaller scales. No matter how much you zoom in, fractals are everywhere in nature. You can find them in the branching of trees, the structure of snowflakes, and even in the shapes of coastlines. These patterns might look simple, but they hide a level of infinite complexity. In fact, some fractals have infinite length, even though they fit into a finite space. Infinity and timeus, we soar through space. Let's consider a mind-bending question. Could time itself be infinite? Scientists and philosophers have pondered this for centuries. If time had no beginning and no end, the universe could go on forever, never reaching a final moment. The Big Bang Theory suggests that the universe had a starting point, about 13.8 billion years ago, when all matter and energy were compressed into a single point. But what about the future? Some theories suggest that the universe will continue to expand infinitely, with time stretching on forever. Others suggest that the universe might collapse back in on itself in a big crunch. No matter what the future holds, the concept of infinity helps us understand time in new and exciting ways. Whether time is infinite in both directions, past and future, or whether it's bounded by cosmic events, infinity opens up endless possibilities for exploration. Conclusion: embracing the infinitious, we return to Earth after this grand journey. Remember that infinity is a concept that stretches the limits of our imagination, from the infinite universe to the smallest particles, and from the repeating patterns of fractals to the unending flow of time. Infinity plays a crucial role in both the cosmos and the mathematics that describe it. Through the eyes of Zoran the Dragon, we've seen how infinity touches every part of the universe. Whether we're talking about galaxies billions of light years away, or the infinitely small points in space and time, infinity reminds us that the universe is far grander and more mysterious than we can ever fully understand. And yet, through math, we can begin to glimpse its endless beauty. In this chapter, we've introduced the infinite possibilities of the universe, grounded in true mathematical and scientific concepts, while letting the story soar with wonder. Infinity may be a challenging idea to grasp, but it opens up new worlds of exploration for curious minds of all ages.